Hello and welcome to the Professor Vector channel. My name is Ed March. Today we're going to look at ViaCad and the workflow. What are all these files when you want a 3D print? When I bought my 3D printer, I was kind of confused. I knew I wanted some kind of CAD program and I needed to print something with G-code, but didn't know how to get there. So we're looking at ViaCad version 2D, 3D, and version 12. So ViaCad V12, the 2D, 3D. And we're going to look at the workflow, and we're going to look at the native file formats. What do you save your files in when you're in a CAD program? What do you export them to? STL files, stereolithograph files, and how do you convert the STL files into G-code with the slicer? And what do you do with those G-code files, and what exactly are those G-code files? So let's open up ViaCad here, and I'm going to show you a keyboard on the screen so you can see as I type, and we're going to create a cube. So our first cube will be 3 inches by 4 inches by 5 inches. Okay, and I'll hit F7 to rotate that cube around. And you can see the dimensions on the cube. So the first thing we'll do is we'll save our cube. Okay, so we will save it as cube 001, and it's a VC3 file. Okay, so the important thing to know is that this cube is in the shape of a cube and not triangles or XYZ coordinates or anything like that. At the high level, we see a cube. We see the objects that we make, whether they're cylinders or spheres or whatever. Okay, so this cube has a part number in the Concept Explorer, and it has a block. So we're at part 53, and inside there is a block. So we're going to export this now. We will hit F12. We will export this as an ASCII file format, because one of the nice things about ViaCad is you can export STL, ASCII, or binary. Binary is by far the most popular and smaller, but we'll show you both. So that's our ASCII file format. And then we'll export it again as a binary. Okay, so now just to show you what an STL file format is, if we were to import either one of these, we'll import an STL file, and we'll pick our binary one since it's more popular. And notice that the STL file stores everything as the smallest, simplest geometric shape polygon, which is a triangle. So this square face is stored as 2 triangles. This one is stored as 2 triangles, 2 triangles. And as you rotate around here, they're all stored as 2 triangles. Okay? So that is our simplest face. And then what we'll do is we'll open up the ASCII file. So we'll look at the ASCII file. First, what we'll do is we'll look at the VC3 file. The VC3 file is a proprietary ViaCad file format. It's in binary. Nothing else is going to read it that I know of except for ViaCad. So that's their native format that keeps the high-level geometry as shapes that you make. Okay, the STL file in ASCII has our name, block 40, in there, and then it has vertexes X, Y, and Z. So these are just groups of triangles. Now we could actually edit one of these and kind of break it to show you what it would look like. So instead of a minus 3.16, let's add an inch to it. And let's save it as the ASCII broken version. Okay. And we'll go in here and we'll import that into here with F11, import an STL file, and we'll do the ASCII broken STL file. Let's see, let's get rid of this one for clarity here. So notice that there's kind of a hole in here because we moved one of those points and it doesn't really connect up. Okay, so that's kind of the inside. We took, I'm not sure which one of these points, probably this one, and moved it way into here. Okay, we moved it an inch further, and that's what it looks like. So if you really wanted to, you were a programmer, you could write up something to edit these STL files. In fact, that's exactly what the slicer does. When we open up the Prusa slicer here, and we get our binary file, I think we're in millimeter mode. I'm not sure why. But it really doesn't. It doesn't matter a whole lot. We'll just scale this up by about 25. Well, that's way too big. We'll scale this up by about 8. That's still too big. Alright, let's try 5. Okay, so there's our cube. It's complaining that it's too big, so we'll have to do 4. Okay, so now we're green and we got a nice size cube. Now notice we can print this a couple different ways. Okay, we could rotate this on the Y. So our print time here is 1 day, 3 hours. Okay, so it's taken a day to print that. That's incredible. If we rotate this 90 degrees and print it that way, it's still generating G-code. Wow. So it's a little bit faster. It's still 1 day and 2 hours. Let's scale this down a little bit more to a factor of 3. And now we got 17 hours, okay? But if I flip this, printing on the Z is the slowest. The X and Y are pretty fast with the printer, but every time you go up to Z, it has to retract the filament and then extrude it and go back and forth, and it takes a long time when it does it thousands of times like that. So now we're talking 17 hours. Let's flip it again. Then we're talking still 17 hours. Not that significant. But what does this generate? Okay, so if we export this G code into this and go back into our editor and look at what that G code is. Okay, so this is the G code. Now G code is very simple. It's just head movement. Okay, so there's, wow. And notice they're big files. Okay, these usually are very big files. So here's some of the so our VC3 file is 6K. Our binary is only 684 bytes. Very small. Our ASCII is 2K, and that's what you see that's what you've seen up here on the screen. But when we generate G code, I mean, look at this. That's 1, 2, 3. We got 73 megabytes for the G code. And what is the G code? Well, the G code, first of all, there's some comments in here that are going to give it a like a picture. But your G1s are the most important things. G1 and G0. G0 goes from XYZ as fast as it could. So it doesn't necessarily draw a line. So if you're going from like here to there, it might go faster on the X and actually come around that way instead of a line. G1 makes it linear, a linear line from point to point. So almost everything is going to be G1 commands. G0 is just for like moving the head around and getting it there fast. G1 is actually doing the work. And then E is how much plastic you're extruding. So you got your X, your Y, and you don't have Z in this case except when they move up and down. Let's search for a Z in here. So there's a Z. Okay, so there's a layer change. So this is what takes a little bit of time. And then you start, then we got a wipe that sometimes it irons on things. There's a lot of different settings that you can use. So this just looks like a solid cube, but let's look at the slicer and see what's really going on here. So in the slicer, so you can see that this is not a solid cube. Okay, so as we move the head throughout the Z, X and Y, sorry, and this is our Z. So this is what first initially happens, right? We're going to lay down our line. Notice there's a first like test line that goes down there, so right there. See that? And then we're going to lay down that first green is called a brim, okay? And then we're filling in our first bottom wall, okay? And you can see this. There's the first wall, second wall, and then it starts doing a infill. Okay, so our infill set to 15%. We can set it to 5%, and it kind of looks like that inside. But notice the bottom walls are still the same because that's the outside of the cube you see. And the same thing with these walls too. So the infill is how much plastic you really want to use and how strong it's going to be. 5% is kind of wimpy. I usually do 15 or 20. You can do 90, but it's almost a waste of time. It's still calculating the infill layers here. I mean, I don't think anyone really prints that high, and at 100% it really doesn't do. So no one, I can't see any reason to ever do 90. Maybe 40 or 50, you know, depending on how strong you want something like that. So whatever you do and whatever you select, that's going to export the G code. And when we export our G code here, that's what the G code is going to look like. And these are millions of lines of code. As you've seen, look at this. Look how many lines of code this is. So this is why you're, you know, taking hours to print this kind of stuff. Because you get, what, 2 million lines of code, 2.6 million lines of code. It's just a lot of tedious little movements. So that's the workflow from going from ViaCad. We're going to show you more of, we'll make a new object, and we're going to load one. So we have a file called 2 cubes that I made earlier, and it looks like that. So you could print this several different ways. Let's get rid of this. And let's open up the 2 cubes, the STL file that was exported before. Okay, so that will not have a problem printing. That'll print just fine. But what if we rotated this on the y-axis 90 degrees and we wanted to print that? That would kind of be impossible, because as you printed these layers, right, as you're printing like this right there, this is not going to keep the hot plastic from falling down on the bed, and this is just going to turn into you know, melted plastic that falls on the bed and just mush, and you're not going to get the shape you think you're going to get. So you're not going to get that. So what do? Well, there's always 3 ways to solve this. 1, print on a different side, a different angle, print it a different way. And as we've seen before, that's one possibility. We can print it that way, and then we don't have any problems. Okay? Because nothing has to be supported in midair. But if we were supporting it in midair, the second solution would be to add support. And you can add support on the build plate. So this is throwaway plastic. This green is throwaway plastic. So when this prints, it'll print with support here. Okay, so that's your support. And when it prints on top, that keeps the actual object supported, and you can actually finish your print. But now this could take a lot of time and waste a lot of plastic, and then you have to get in there with a knife or wire cutters and chop all this stuff out and throw it away. It once took me an hour to take out the support plastic on a jug jar holder that I made. And the other third way is you could print these in two pieces and glue them together. Maybe make them interlocking somehow, which we'll cover in another video, and then glue them together. So, you know, think about printing things in pieces and parts. And then once you get this, you export this G-code and you get that file. You send it to your printer flash drive over the network or however you want to get it there, and start your job. And wait and be patient. So that is the whole thing, going from ViaCad then to different file formats to slicing. The slicer is the magic, has a lot of tricks and a lot of settings. And so I hope you liked this video. I hope you got something out of it. And if you do, remember to like, subscribe, and ring that bell and see more videos like this. I'll see you in the next one. Take care.